Welcome to Physics Made Easy channel, and the next topic is Rutherford's atomic model, and this is one of the very easiest articles. You could have gone through this in your chemistry as well. Now let me go through the basic points. The atom is made up of very small central core. Atom is made up of very small central core called atomic nucleus, and the size of the atomic nuclei is of the order of 10 raised to power minus 15, and the size of the atom is of the order of 10 raised to power minus 10. Size of the atom is in angstrom. Note this, size of the atom is in angstroms. Angstroms atom. And size of the nuclei is in Fermi, or the nucleus size is 10 raised to power minus 15 meter. This is known as 1 Fermi, and angstrom, we know this is 10 raised to power minus 10 meter. This is the size of 1 to 10 angstrom. It varies 10 raised to power minus 10 meters to 10 angstroms. This is the size of an atom, and then the size of a nuclei is 10 raised to power minus 15 meters. Now, Rutherford, on the basis of his experiment, he said that the whole of the positive charge is concentrated on the nuclei, that is the central part. Entire mass of the atom is concentrated at the nuclei. The atomic nuclei is surrounded by a certain number of electrons. These electrons revolve around the nuclei of various circular orbits, as do the planets around the sun. So there is a nuclei, and this is the nuclei, and electrons in various orbits, they revolve around the nuclei. This is what we say is Rutherford model. And he picked up the analogy from the motion of planets around the sun. The only difference is that he assumed the orbits to be circular while the planets revolve around the sun in elliptical orbits. The centripetal force needed for revolution is provided by electrostatic force of attraction between the electrons and nuclei. Now, centripetal force F centripetal is equal to F electrostatic. Now, the formula for centripetal forces mv square by r. This formula is mv square by r. This is equal to electrostatic force Ze into E is 4 pi epsilon naught r square. This is 4 pi epsilon naught r square. Now, F centripetal force is F electrostatic. The centripetal force is balanced by electrostatic force, or we can say that electrostatic force provides us the centripetal force. The atom as a whole is electrically neutral. That is, total negative charge of electron in orbits is equal to total positive charge of the nuclei. Now, electron orbits. Let the mass m be the mass of electron and E be the charge revolving around the nuclei having charge Ze, and the radius of the orbit is r. Let us assume this case. In this case, it's quite clear from the diagram that electrostatic force, I will call it as Fe. Now, electrostatic force Fe is Ze charge on whole of the nuclei. Note it, this is Ze. E is the electronic charge multiplied by E, Q1, Q2, and K is here, and this divided by R square. This is the formula for electrostatic force. As the velocity of this electron is V, So F centripetal force will be, if m is the mass of electron, this is mv square by r. Now we have already stated that Fe is equal to Fc. Now if I use this formula, from here I can get the formula for kinetic energy directly. So the very first thing that we will obtain from this formula is the formula for kinetic energy. Let it be equation number 1 and let it be equation number 2. Now equation 1 is equal to equation 2. This clearly says that I will write it here because of m v square by r is equal to k z e square by r square. This cancels. It means m v square is k z e square by r. From here, kinetic energy. Now I have directly picked from this equation 3. I am writing equation 3 here. Kinetic energy is equal to half mv square. We know. Now I am substituting the value of m square, and this is k z e square by twice of r. Now I will substitute the value of k. So it will come out to be z e square 8 pi epsilon naught into r. This is the value of kinetic energy. So this is the value of kinetic energy. This is the formula for kinetic energy. On the same lines, we can derive formula for radius. It's not that easy, that tough. Formula for radii. Suppose I have to make calculations about the formula for this is the relationship. From here I can even calculate the formula for radii. So we can calculate radii, and the radii will be equal to r. Small r is z e square divided by 8 pi epsilon naught into kinetic energy. Now fill the value of kinetic energy and we will get z e square. Half will make this 8 pi to be 4 pi. So I shall be directly writing here 4 pi. So this is 4 pi because the here was half mv square. Now I shall be writing mv square because 8 divided by 2 is 4. So this is the formula for radius of the orbit. On the same lines, we can, from here we conclude that, from here what do I conclude? Radii is inversely proportional to kinetic energy. The more the kinetic energy of the particle, lesser will be the radii. And the next is, we can even find out v square from here as well. Let it be equation number 5. Now equation 5 gives us velocity v square to be equal to z e square divided by 4 pi epsilon naught into mr. This is the formula for velocity. Now I have got all these formulas. One is the form. Now let us go through various formulas. First we made use of this equation that F centripetal force is equal to F electrostatic. Centripetal force is mv square by r. Electrostatic force is zd square divided by r square. From here, I got the value of mv square and hence the formula for kinetic energy. Now, this is the formula for kinetic energy. This is basically the formula for kinetic energy. From this formula, we can even get the value of radii. And I concluded that radius is inversely proportional to kinetic energy. Larger the kinetic energy of value, smaller will be the radii. And from here, I can calculate the value of v square. V square is Zd square by 4 pi epsilon naught mr. So these are the values. And now, the last value is of potential energy. Potential energy U. This is Ze into minus E. This is 4 pi epsilon naught into R. This is minus Ze square by 4 pi epsilon naught R. This is potential energy. So this is the formula for potential energy. So we have already drawn the formula for kinetic energy. Let it be equation number 7. Formula for kinetic energy is, which is positive, Zd square divided by 8 pi epsilon naught R. This is kinetic energy. Equation number 8. Now total energy E is kinetic energy plus potential energy. So both these equations are same. So now what will be the formula of kinetic energy? No, sorry, total energy. This minus this. This minus this. Kinetic energy is half of the potential energy. Now the total energy will be equal to half of the kinetic energy with negative sign. Ze square by 8 pi. Let me write it. Let me. So this formula will become Ze square by 8 pi epsilon naught R square. This is equation number 9. Equation number 9, total energy is negative. If total energy is negative, it means the motion is bounded. Negative energy means motion is bounded. Positive energy means motion is not bounded if the total energy is positive. Again note, potential energy is minus Ze square by 4 pi epsilon. Kinetic energy is half of the potential energy. That is Ze square by 8 pi epsilon naught R. Kinetic energy is positive, potential energy is negative. When we add them up, we get total energy E is equal to minus Ze square by 8 pi epsilon naught R. So this total energy is negative. This tells us that the motion of electron around the atom is bounded. So this total energy, he has written the formula here. This is negative. Total energy negative. This implies motion is bounded. Now, atomic spectra is out of the preview of the syllabi. but still I will give you an overall view. Atomic spectra. Atomic spectra, if an atomic gas at low pressure is excited, it emits radiation of certain specific frequencies only. A spectrum of such frequencies is called emission spectrum. Line emission spectrum contains few bright lines on a dark background. So this is emission spectra. If white light passes through same gas vapor, then we see a few dark light. When we see dark light on bright background, the spectra is absorption spectra. When we see bright lines on dark background, and that spectra is emission spectra. Spectral series of hydrogen. Spectral series, what is spectral series? Spectral series is a set of lines. The spacing between the lines of certain sets of hydrogen atom decreases regularly. Now, we have got Lyman series. First series is Lyman series. And then Lyman series. The wavelength varies from 91 nanometers to 656 nanometers. Then we have Balmer series. Balmer series wavelength varies from 364 nanometers to 656 nanometers. So this is Balmer series. He has shown Lyman series 91 nanometers to 122 nanometers, and then Balmer series 364.6 nanometers to 656.3 nanometers. So from 90 to 120, from 90 nanometers to 120 nanometers roughly, you can say Lyman series, and from 364 nanometers to 656 nanometers, you can say Balmer series. And Balmer series, this is an empirical formula for Balmer series. Note it. This is the empirical formula for Balmer series. We will drive it in Bohr atomic model. Empirical formula for Balmer series. When Balmer series is formed, when electrons from higher shells, they fall in second shell, Balmer series, Lyman. Balmer series, Lyman series is in ultraviolet region. This is in ultraviolet region. Balmer is in visible region. You can see it from Balmer is in approximately visible region, and Lyman is when electrons from higher levels, they fall in the first level, and Balmer series is in visible spectra. This is the Balmer series. This lies in visible part of spectra. Lyman series is when electron falls in first level, and this is in ultraviolet region. Lyman series is in UV area, ultraviolet region of the electromagnetic spectra. And the next series is Parchan. Parchan series falls in, remember this, infrared region. This is the Parchan series is formed in infrared region, and in this case electron from higher level, it falls in third level. And the next is bracket series. Bracket series, electron falls in fourth level. From higher level, electron falls in fourth level. And then we have got Fund series. In Fund is far infrared. Note, Parchan is infrared, and that bracket is also in infrared region. And P Fund series, this is in far infrared region, and in this case electron falls in fifth energy level. Electron falls in fifth energy level. Now, there is no logic to justify the presence of certain frequency oblique wavelength in hydrogen spectra. Now, the next is limitation of Rutherford model, which we shall cover in my next lecture. So I request all of you to view these videos, and if some improvements are needed, then kindly comment, otherwise share the video. Thank you very much for being with me for 20